optimal minimal.
At this altitude, I can run flat out for a half mile before my hands start shaking.
Can I ask you a personal question?
Now would seem an appropriate time.
What if I did the opposite?
I'm a cybernetic organism, living tissue over metal endoskeleton.
This episode is brought to you by AG1, the daily foundational nutritional supplement that supports whole body health. I do get asked a lot what I would take if I could only take one supplement. And the true answer is invariably AG1. It simply covers a ton of bases. I usually drink it in the mornings and frequently take their travel packs with me on the road. So what is AG1? AG1 is a science-driven formulation of vitamins, probiotics, and whole food sourced nutrients. In a single scoop, AG1 gives you support for the brain, gut, and immune system. So take ownership of your health and try AG1 today. You will get a free 1-year supply of vitamin D and 5 free AG1 travel packs with your first subscription purchase. So learn more, check it out. Go to drinkag1.com/Tim. That's drinkag1, the number 1, drinkag1.com/Tim. Last time, drinkag1.com/Tim. Check it out. Hello, you sexy minxes. This is Tim Ferriss, and welcome to another episode of The Tim Ferriss Show, where my job is to attempt to deconstruct world-class performers. I interview the best of the best, whether they be chess prodigies, hedge fund managers, billionaire startup investors, actors, politicians, special ops operatives, and generals, and everything in between. What I try to do is tease out the routines, the habits, the first 60 minutes of their day, favorite books, all the tools and tricks that you can apply to your own life to emulate and hopefully replicate a lot of their success. And this episode is by popular demand. Many of you have asked for more scientists, especially more unorthodox scientists. And you've enjoyed past episodes with Dr. Peter Attia, Dr. Rhonda Patrick, among others. Those were very, very popular. And today I bring you Adam Gazzaley. Adam Gazzaley has been requested by name, and now you have him. So Gazzaley, the Gaz Monster, the Gaz Man, no one calls him any of those things, but he's a buddy of mine. Dr. Adam Gazzaley got his MD and PhD in neuroscience at the Mount Sinai School of Medicine in New York, then did his postdoc training in cognitive neuroscience at UC Berkeley. Now he's the director of the Gazzaley Lab at UC San Francisco, which is a cognitive neuroscience lab. And I've spent time in the lab with things stuck to my scalp, getting zapped, both as a subject, but also as an experimenter, a very novice data gatherer. And I thank Adam for letting me bumble my way through that. Adam has a very unique research approach. In his lab, they use a powerful combination of tools that are very often used in isolation, but in his lab, they're combined. So that includes fMRI, EEG, and transcranial magnetic and electrical stimulation. Now, the last category, this stimulation, has become a hot subject because you have people playing, say, first-person shooter games where they're taking a 9-volt battery equivalent in charge and applying it to their scalps to improve accuracy. It's trippy stuff. And to start with, his research using these tools and others has expanded our understanding of the alterations in the brain that lead to age-related cognitive decline. But that's not enough. Obviously, for me, most important or most interesting to me, his recent work goes far beyond description. He and his lab are exploring neuroplasticity and how we can optimize our cognitive abilities, even if we're healthy, via engagement with custom-designed video games. And of course, then that leads to the question, what happens when you combine these games with neurofeedback, electrical stimulation, or even performance-enhancing drugs? What about using all of them at once? Well, that's just one of the things that we cover in this conversation, which is very wide-ranging, and it gets dense in a few areas. Bear with it. Listen, you will pick up a lot, but we also talk about how he came to be as good at what he does as he has. That was a hell of a sentence. And his routines, all the things that he does to bolster a world-class operation and world-class performance. So without further ado, please enjoy Adam Gazzaley. Adam, sir, welcome to the show.
Thank you very much.
So I am stoked to be in this beautiful office. I've been in the cave all day. You have more sunlight in your office and lab. We're here at UCSF, and the name of the lab is?
Gazzaley Lab.
Of course. Very well named. And I've had my brain shocked here. I have, I suppose, participated in shocking other brains, to use a scientific term. And you have parallettes under your desk.
Yes, I do.
For working out. And I've just found your entire career so fascinating. We've spent a lot of time together, and I wanted to have you on the show to just explore all the nooks and crannies of this multifaceted life you've designed for yourself. And I thought we could start with, of course, you're very good at hosting parties. So when you're at such a party, your own party or otherwise, if somebody asks you, what do you do? How do you answer that?
Ooh, it's not an easy question at a party, but I definitely get asked that one. I usually start by saying I'm a neurologist and a neuroscientist because it sort of lays the framework from my perspective. But if I have to get into a very short answer, then I dive right into the fact that my lab is interested in pursuing how we can enhance cognition to improve quality of life.
And you have a magazine cover outside of this lab on the wall, and that is Nature. And you have work that is the cover story. What is that work? What is the tagline on the cover?
Yeah, so Nature was kind enough to put the title "Game Changer" on the cover of the journal, which is quite a favorable pun for our lab, I would say.
And in the game itself, so that is a reference to, I guess it was NeuroRacer in this case.
Yeah.
And the why was that such a game changer in their mind?
Well, it's a good question. I think that what that paper was able to show that had not really been documented well before was that a team of scientists could work with video game professionals to build something customized that targets a process in the brain that's deficient in a certain population. In this case, it was older adults and their cognitive control abilities. And then after you build that game, you can go through a careful placebo-controlled study with neural measures to document the mechanisms of the effect and show that you can create sustainable and meaningful changes in the brain using a video game.
So the aspect that I found most fascinating is the sustained part. So if we're looking at using very simple video games, but video games that can be made quite sexy to say reverse or mitigate the cognitive decline associated with the progression of age. What did you see in terms of the persistence of effect? Did they have to do it every day, or that just fell off a cliff?
Well, that was actually one of the most surprising findings of this study. So it took us a year to build the video game. We worked with friends of mine that were professional video game designers and engineers and artists at LucasArts back in 2008. So after a year of development, it took us 5 years to do this study, which involved looking at lifespan changes from 20 to 80 years old and using the game as a therapeutic to improve cognition. Our study involved 1 month of gameplay by older adults, healthy to 60 to 80-year-olds around the Bay Area, and they'd play it for 1 hour a day, 3 days a week for 4 weeks. And then we looked before and after at what changed in terms of their cognitive abilities and what changed in their brain. Around 6 months or so, pretty much around 6 months, I realized, wow, we should at least bring these folks back and see what's going on.
As a follow-up.
As a follow-up. It wasn't really planned or funded in the study. But we saw such profound changes in this group a month later that we just wanted to take a peek. So we took these laptops back from them. Many of them were upset to have lost access to the game, which is pretty funny because they were pretty much all technically non-savvy, to say the least, before they started playing. And they get really good at the game and they feel a connection with it. So they haven't played the game in 6 months. We bring them back. And we just had them play the game again. And what we found, shockingly enough, was that their ability to multitask on this game, which is a notoriously challenging activity for older adults, as we've documented in dozens of papers over the years.
Not to interrupt, when we say
Sure.
older, when does that start to, is it like a 30 plus, you just start to lose incrementally this ability?
Well, traditionally we tended to think of older as 65, and then it was 60, and then it was 50. And now from my perspective, older is being more, older than 23 years old. Because when we look at cognitive abilities, especially like these very fluid control abilities, processing speed, working memory, attention, we find that you pretty much decline from 23 on. But in this particular study, usually when you're just doing a comparison between age groups, you tend to go for 20-year-olds compared to 60-year-olds to sort of maximize those effects if you only have limited funding and you can't do the entire lifespan. So we were pretty surprised to see that their ability to multitask in this game, in this 3D environment, had not declined 6 months later, even though it was very deficient prior to training, reached levels of 20-year-olds after a month of training, and then preserved at the 20-year-old level for 6 months. Had we known that, we would have done a lot more detailed study to see what other skills persisted. And in our current studies, we're doing that. We're very focused on the follow-up and to see this sustainability. What does it mean? What causes it? It's definitely very exciting.
It's so amazing to me because it brings up all sorts of interesting questions. And I mean, you're the master at formulating these questions. And you're also I think a master at not fooling yourself, right? I mean, as a scientist, you have to really question your assumptions and look for alternate explanations for what you think is happening. But I remember, just before we started recording, we were talking about Arnold Schwarzenegger and how anxious I was before interviewing him. But when I asked him about transcendental meditation, what I thought was so fascinating is he said that he embraced TM, did it on a daily basis for something like a year, and then felt even years later that the effects had persisted. And if that is the case, there are many different ways you could explain it, but if you're, let's say, trying to tie it together with NeuroRacer and other tools, what are the theories or the plausible explanations? Is it some type of plasticity change? Is there a biochemical element? What are the possible explanations for that or mechanisms?
Yeah, I would say that there's two main mechanisms for sustainability effects, such as, we found in our study and other people have observed in their lives. And one, is what you just described, plasticity. So our brains are plastic, meaning that they modify at every single level from structure to chemistry to physiology, all in response to interactions with the environment, right? It's the very basis of all learning. And plastic changes, when they occur in a deep way and involve all those multiple levels of change, can last for quite a long time. So it's possible that the changes were deep enough that the system just reached a new sort of homeostasis, right? In addition to our brain being plastic, it also has a great deal of stability as well, right? It just doesn't change very easily. That would be very dangerous and detrimental. So it's possible that it's been moved into a new, more optimal state, and then that state preserved just because the plastic changes were so profound. Another possibility, which is interesting, and no, I don't think any less interesting, but a different one, is that you engage in training that's very different, that then moves your brain into a different state and a different set of abilities that you didn't have before. It's possible that because of that, you have now modified your behavior and how you interact with the environment, and that new manner of interaction is what leads to the sustainability.
So what would be an example of that?
Here's a sort of lowball example, right? Not so complicated, but let's say you go to the gym for a couple months and you get some benefit, right? Now, no one really thinks that if you stop working out for a year, that benefit will maintain, right? We got a pretty good idea that you do need to keep sustained physical activity to see a benefit. But so you stop going to the gym because you moved and the gym's no longer accessible for whatever reason. You let your membership run out. But then because you're feeling more empowered by being in shape, you start taking the stairs and not the elevator. And so there is an example, sort of obvious one, of a change that you made in your life, a behavioral change in response to the training, right? It was caused by the training. But that change in your life then leads to the sustainability of those effects, not because of the direct effects, but because you continue to exercise them in a different way than you were trained on.
Which is very common, right? I mean, for instance, if you're looking at behavioral change and you want to get someone to change their diet, but if you're disallowed from saying change your diet, get them to start exercising, and they'll start being more conscious of health-related decisions across the entire spectrum of their activities.
It's what we always hope happens, right? Because that really has profound effects and reverberates. You get this cascade of beneficial effects that feed on each other. So it was caused by the training program, but the sustainability of it is caused by the behavioral influences that training program have that then allows you to maintain.
And the Nature magazine, I suppose it would be better called a journal, or
Yeah, it's a journal.
yeah, with a very nice glossy cover on it.
Well, yeah, there's like two top science journals, general science journals in the world, Nature and Science, and Nature being one of them, and not publishing a ton of paper on video games.
So Nature, as I understand it, and please correct me if I'm wrong, having the cover of Nature is kind of like in the business world, walking into the airport on the way to your gate, and your face is on the cover of every business magazine. Because there are dozens and dozens of business magazines, but like you said, there are kind of two big players in this space. How did that feel when it was 100% and you were no longer worried about bad juju and jinxing yourself, when that day came when you knew it was 100% you were going to have the cover of that magazine?
I mean, it was definitely ecstasy.
Where were you? When did it really, when you were like, okay, now it's 100%?
Yeah, I was, not in a very glamorous location, sitting in front of my computer checking email, of course, is the way I found out. It's not like someone drops in on a parachute with a big,
gives you a golden ticket.
Exactly. It's not quite dramatic. But, it was incredible because you spend, your whole life. I did an MD and a PhD, and I was in school for 18 years after high school, and just a long pathway, and then build a research program, create a lab, do a very risky study that most people thought was crazy, building a video game to rewire brains of older adults, and go through all those stages, and then just the act of getting published is just incredibly grueling. And then obviously go all the way to being accepted into Nature, and then the cover. It's just a very drawn out, painful process. So when it ends, like you said, in one moment where it's there, it's absolutely thrilling.
And the risk that you mentioned, I think is an interesting topic to explore with you, because you've crafted a very, from my perspective as an outsider, but also from the perspective of PhDs who have worked with you, Daria, for instance, a very unorthodox setup here for yourself. What gave you the confidence to build the game and tackle that, despite the perception by many people that it was a very risky thing to do? Like, what was the internal self-talk? What allowed you to do it?
I mean, mostly it made sense to me. To me, it was a logical approach. We've been building up confidence in the video game genre in general as being able to transform or to have an influence on behavior. Our research had pointed to it in many directions that this was possible. And to me, it just seemed that it was time that we challenge the system, not step in the footsteps of everyone that went before us. Much of the field looks at molecular approaches, pharmaceuticals, and I was incredibly excited, as everyone is, about all the innovation in the tech world, and to be able to bridge that with neuroscience for health outcomes just seemed incredibly exciting. And I've never really been too afraid of doing things like that, of stepping out when it seems risky.
Why is that? Do you define risk differently from other scientists? Or is it from experiences you've had that other scientists haven't? Because it is a very, when looked at sort of amorphously, it's a risk-averse community, it would seem, in a lot of senses.
I think that we were sort of trained to travel through our scientific careers in a very iterative process. You build on the discoveries that came immediately before you, and you advance them. And that's not really how I want to do science. I want to do fundamental breakthroughs if possible. And so if you have that mindset, if that's how you challenge yourself, that's what you want to do with your life, with your small amount of time that you have here to make a difference, then the only way to do it is to do the type of research that other people would think of as risky or even foolhardy. That's just part of the game.
Which person, historical figure in science or elsewhere, do you most admire?
Well, I could tell you who I was most inspired by. When I was a kid, I didn't grow up with science or medicine in my life. I grew up in Queens. My parents didn't go to college. No one in my family did. And they were very academic, supportive of me as a kid. But I just didn't have that influence. And I was watching Carl Sagan's Cosmos series, and and I know it's a pretty common one because I've heard other people, but it was a really powerful, just friendly way of being introduced to complexities and wonders that was gripping to me as a kid. And I watched it with my dad. It was a great bonding for us, and the way he delivered it was just captivating, and it was really what sort of sealed the deal for me that I wanted to be a scientist.
When you decided you wanted to be a scientist, was it just a scientist, or was there an area that you thought you wanted to explore?
Well, I decided somehow that I wanted to be a scientist at age 7 before I actually knew what that meant. But I think I was largely very stubborn. And so if someone asked me, what do you want to be when you grow up? I'd say a scientist. And I kept saying that my entire life. And maybe that's why I'm a scientist now. At some point, it's probably around when I was exposed to Cosmos, I thought I wanted to be an astronomer. Something in that space, whether it's more on the physics side or, astronaut side. I didn't really know, but I was really captivated with the cosmos, and it was missing something for me that I didn't know until I discovered the brain and neuroscience research, which was when I was an undergraduate, so not really all that young.
Where did you do your undergraduate?
I was in upstate New York at Binghamton University, and I was at I was a biochemistry major, taking one of the very few non-science classes that I was required to take. I feel like if I could go back, I'd take all humanities classes, but at that time I had a pretty heavy science schedule. This class was called History of the Future, and they were talking about
an amazing title.
It's an amazing title, and it was an amazing class because it really tried to capture lessons from our past that guide how we view the future. And one of the other elements of the class was to see movies like Soylent Green and Planet of the Apes, and it's just amazing. Like and these were obviously very popular class. And one of the lessons was on the future of the brain and nanotechnology in the brain, and I had not really thought about the brain. And when I literally immediately went to the library the next day and took out like 40 books, just, 20 at a time, just carrying them back to my room. And I felt like that same just immense excitement when I first discovered cosmos and astronomy, but in a much more profound way because it was more connected with people and humanity. And that's what I always felt missing. The space was looking out and this was looking in. And so at that moment, I knew that I was going to spend the rest of my life on, now it's 30 years later.
What does that excitement feel like? Because it's very different from the excitement that you would feel if you just drink too much coffee, for instance, right? I would imagine. For you, what does that feel like when you're like, oh, I think I'm about, like, this is the precipice or the springboard.
I mean, I think it's what people feel when they describe having an epiphany. It's a transformational feeling. It's a type of sensation that you will never be the same. Like something has fundamentally shifted in you that will last probably the rest of your life, which turned out to be true.
Yeah. What makes this lab unique or unusual?
Well, we are unusual in several respects. The first is that we do some very basic science in this lab. So we try to understand how neural networks in the brain underlie higher order cognitive abilities, attention, memory, perception. We try to understand how those abilities of our brain are vulnerable, for example, to distraction and multitasking. We look at how the brain changes as we get older in that regard. So I classify all that as sort of basic science. We're trying to understand how the brain works.
You're using a lot of imaging.
And we use functional MRI, EEG, transcranial stimulation, tools of human neuroscience, right? Human cognitive neuroscience. In that sense, we're similar to many cognitive neuroscience labs. But we do something different, and now it occupies more than half of our lab's efforts. And that's, we also have a research program to say, how can we use our expertise, our methodology, our perspectives to not just understand the brain, but to try to develop novel approaches to enhancing it and then validating that our approaches are actually effective. So to be able to sweep across the breadth of discovery to invention to validation, and then even filing patents and moving concepts out of the lab into industry to really connect at that sort of scope, I don't really know any other labs that do that. So I think that's a really unique aspect.
I think it's very ballsy too, in so much as, and again, this is just from someone who's spent a lot of time around scientists, but who has never practiced as a real serious academic in any way in the hard sciences, is that you're not only describing these basic scientific phenomena and answering these science questions, but you're also bleeding into the prescriptive, right? Where you're looking at recipes and technologies that can be used to improve function, potentially even in so-called like normal healthy adults, right? That's, I think, one of the many reasons we get along so well. But, what are some of the concepts or the insights that have made the jump out of this lab into the private sector?
Yeah, so it was, just to reflect on that a moment, sort of when that happened. It was around 2008. So I've been doing this for a long time already. I already had my own lab, already made some really important discoveries on the brain and the aging brain and distraction and multitasking. That's what I was largely known for in my research. And then I basically became a little dissatisfied at just reporting the bad news, that our brains were fragile in ways that we didn't fully understand, that it all got worse as we got older. I mean, that's like a great intellectually fascinating story for a bunch of scientists. For the general public, it's sort of a crappy story.
It's not the happy ending we're hoping.
No, I joke around, the first time I gave a big talk to an audience of older adults about our discoveries on the aging brain, and I closed the talk, I feel, I was staring at all these faces, and they had the look on their face like, wow, I'm watching a movie, everyone died, and the credits rolled. And they're like, that sucks. And I was like, this is not how I want to end the movie. We could have gone on for another 40 years, as most labs do, and try to understand all of the details and complexity of why these things happen, why our ability to focus and our attention declines with age. And we're going to continue to do a lot of that. But to be able to actually create things that can help these people, that's what is something I always wanted to do. And I wouldn't say I lost track of it. It just took a long time for us to get to that point that we could do it in a responsible way. So over the years since we've had that transition, and it really started with NeuroRacer, now has become much more extensive and expansive in our approach. The things that have left the lab are really largely built around our design principles on how we construct games from scratch, working with professionals, because I give a lot of respect to video game professionals and artists and designers, but we work very closely with them and create the algorithms and how multiple algorithms interact with each other to challenge the brain in an adaptive and high feedback way that actually leads to change. And so that's what most of my patents surround, that concept that you can build that methodology to advance how our brain functions.
And the algorithms, this is where I massacre concepts that are sacred to a lot of people. But so is it safe to think of the algorithm as, in this case, I guess probably sort of an adaptive algorithm, which is a series of kind of if-then statements that are formulated in a proprietary way and ordered in a proprietary sequence?
Yeah, that's appropriate. I mean, we tend to think of them rather than if-then as a full closed loop. So, that's how we sort of visualize what we're doing. We're creating a closed loop between an intervention. So you intervene in some way, you record the impact with as low latency as possible, right? So as short a time as possible, you see what happened.
As little delay as possible.
Little delay. With that information, we then cycle back, reformulate the intervention, apply again. And if you do that with as little delay as possible, you create this very powerful closed loop feedback system.
Got it.
And that is the most powerful way to change anything, whether it's a physical system with, a diamond drill and, you're trying to, pummel into the earth, or you're trying to change a biological system like the brain. Our current approach to therapeutics and improving the brain, largely in the pharmaceutical world using molecules, is a very open loop system. Very long time delays between the intervention, knowing what's happening, even the ability to know what happened is usually not quantitative at all, and then a very poor feedback system that leads to updating it, right? I mean, just imagine you go to the doctor, you have an attention problem or depression, you take a medicine, you go home, you subjectively record the effects and side effects, you go back a month later, you recount them, and then, we're going to go up on the dose a little bit. Yeah. And, that is just not a way to change something, especially something as complex as the human brain.
Playing darts with a blindfold on.
Yeah, and that's like the basis of like our entire mental health care system.
For a month.
And some people respond well, and maybe they got lucky, and other people are just struggling. And this is, a broad, big global problem. We don't have effective means of improving how the brain functions across people that are suffering, that have disorders, and people that are healthy and just trying to improve their brains.
When you think of the word successful, who's the first person, or who are the first people who come to mind?
That's a really good question. I mean, I think I've spent too much time thinking about people that are not successful to answer that question immediately.
Why have you spent so much time thinking about people who are not successful?
Well, maybe not people that are not successful, but approaches that are not successful, because I'm trying to find the holes in the system, the way of changing it in a meaningful way. And to do that, I'm looking for where we're missing the boat.
And by system, you mean just this kind of scientific establishment?
Yeah, changing the scientific establishment, but changing more of what we think about as medicine, especially when it comes to the brain. And I'd say education when it comes to the brain. So, it's probably, I don't know, maybe it's a fault, maybe not, but I really don't spend a lot of time looking at success cases. I really spend most of my time looking at where we're not reaching the high bar that we should be, both in education and in medicine.
How do you vet people who want to be in your lab?
Most people that want to meet in my lab are pretty aggressive at trying to get into the lab. Usually that's a good sign.
It's not many people, just so for those listening.
Yeah, we have a core group of full-time, FTEs on the payroll of a little over 20, but our extended team of interns and volunteers and, is close to 100 people. So it's quite large. A lot of people come in the lab and spend time volunteering or interning just to get to know what we do and for us to get to know them. I'm looking for people that are very rigorous, very careful. I like people that are, how I describe it, sort of optimistically cautious. They're conservative in that they're not overinflated in what they say, but they're excited and they're enthusiastic and they think, that there's something really here that drives them to be here.
How do you establish that? So the rigorous side. I mean, is it just all on their resume, their CV, or are there sort of behaviors you look for, questions you ask in interviews?
No, I don't really have like a really tight methodology on how I do that. A lot of it is that connection you get with someone when they're talking about what they do, what excites them. I mean, that's usually where I start. What do you think about that really gets you excited? Because I'm more interested in what drives someone and motivates them and makes them want to get out of bed in the morning than a list of, classic resume check boxes. And once I hear that and look at them and hear them and, obviously in the context that they have been successful in many ways and have the type of requirements that we'd want in this lab. But once we have that back and forth, then I know that that's, the person that's perfect for this place. What
are common misconceptions about the brain or cognitive function that just refuse to die? Like, I'd love for you to comment on as we all know, we only use 10% of our brains.
I was going to say that one.
So could you just dive into that for a second?
Yeah. I have been unable to find where that originated from. The best I could find is that it seems that when the early researchers were exploring brain function in different areas, they would, in animal models, they'd make little ablations. They would destroy little areas of the brain and look what was happening. And there were large areas of the brain that you can do that to that you wouldn't see an impact. You wouldn't see a negative impact. You do that over the motor cortex, over the sensory cortex, over the visual cortex. Bam, you can't see, you can't move, you can't feel. We know that this does that. But there's lots of areas of the brain whose function is a little bit more mysterious, and you have to see it a higher order way that you can under anesthesia or even in animals. And so it started leading to the impression that there were some areas that just didn't seem to be doing anything. We now appreciate that that's not true at all. The most complex structure in the entire universe doesn't have just like a vacant parking lot, waiting for someone to drive in and start building. It's all used all the time, and in complex ways that we didn't always understand. I mean, for a long time, we tended to think about brain areas as sort of like islands of blobs of function. We now know that real higher order brain processing and function comes more from network interaction, how brain areas are communicating with each other. And so one brain area might do something very different depending on the context of what other brain areas that it's communicating with are doing at the same time. So it's a very complex, we call multivariate system that's dynamic and constantly changing over time. And I think this complexity that we've only really recently begun to understand to any degree led to sort of very sort of naive views of the brain that we didn't use at all.
What are some, and the idea that there are very specific, discrete areas of the brain that are kind of like separate people on an assembly line who only do one thing is still very persistent. And I mean, it's very
I'd say it's another sort of myth of the brain.
What are some red flags that people can keep in mind to avoid the charlatans who claim to be scientists of the brain? Because there are a lot of people running around kind of jumping up and waving their arms and so on.
It's a frustrating thing for scientists and neuroscientists. And to speak specifically what I mean by that, the brain and science in general could be a very powerful marketing tool. It's have millennia of successes and technology, which is right in our face all the time, really grew out of scientific exploration. And so we're constantly reminded at what a powerful tool science is. But the challenge and the way you can think of challenging someone that you think might not be using science in a legitimate way is that science is not really about what we have done. Science is a methodology. Science is an approach. And so basing something on science doesn't really make that much sense to me. I mean, almost everything is based in some way on science. If it's not based on science at all, we shouldn't almost even be talking about it, or it really falls into another realm. Because
you're talking about rational inquiry and a sort of structured way of thinking about evidence or lack thereof.
Yeah, and we have this really, really massive framework that we've built to understand the world that gives us so much leeway into how we consider things that basing something on science is super low bar. It doesn't mean that much. Like in the next hour, we could sit here with a glass of wine and put 1,000 things based on science on the board.
Right.
What's more important and what's sort of being used in an imprecise way is the concept of being validated by science, and what that means and how hard that is to do, and the details and the complexity of getting there in a rigorous way that's peer reviewed and defensible and reproducible. That's a different story. And so the basing on science is not so exciting to me. The being validated by scientific methodology, that's what we're all trying for. And I think that people should keep that in mind when they're reading something about science. What is it really just being used as a marketing, weapon or tool, or is there really a careful description of the research approach that went into it, and of course those limitations that exist that are inevitable? Everything has those.
And I think that's a huge one for me. Is if someone is painting their data or their approach to be the best, the perfect, mm-hmm. and they're not very upfront about the limitations mm-hmm. or the potential flaws in the data, mm-hmm. That to me just reeks of mm-hmm. pseudoscientists.
Yeah, it's impossible to do something that doesn't have a long list of limitations. I could easily go through them of my work, and I do all the time. Some of the complexities are driven by the media. I spend a lot of time with the media trying to hone my message and make a balanced message. And if you look, and you'll see I have articles in, New York Times, New York Magazine, I'm quoted, and you'll see, these little disclaimers and these balance points that I work very diligently with those journalists to say, hey, could you put this in for me as, a sort of thank you for me taking the time to do this interview with you, because without this, it's just not fully balanced.
Right. Yeah.
But if you don't do that, very frequently you wind up with something that's really only capturing the highlights. And it's not that the highlights are wrong. They're just not the complete story. They're incomplete. For example, in our research and even our Nature paper, we're massively excited by the elements we found, but it is a step one. In my mind, it is a proof of concept. It's the reason we get excited that we have a signal there that something's going on that leads to larger studies to reproduce it and to show even more aspects of its sustainability. And also, we never even looked at how those changes in the brain and cognition translate into people's lives. We would have needed much larger numbers, and it's very hard to even tell that in any study because we don't have great quantitative markers of how someone's life is being impacted by something that we're doing. So those are just obvious limitations to me that I like to also express in addition to the things that we're excited about.
Is it possible that, or what is the likelihood, do you think, that some video games that are already out there, pre-existing video games, have some of the cognitive enhancement effects or maintenance effects that those devised in the lab do?
I think it's beyond likely. I think there's no doubt that is true. As a matter of fact, we were inspired into the video game research in a pretty profound way by the work of colleagues of ours, Daphne Bevelet and Sean Green, who showed also in a Nature paper. There's only several Nature papers on video games, but another one in 2002 showing that consumer video games, first-person shooter games, the games that some people have the most trouble with because of the violent nature of them, that young people that played them would show much superior cognitive abilities compared to their peers that don't play these games. And if you take someone naive that doesn't play video games and you have them play it, you also see these effects, especially compared to other games like Tetris. And so I would say undoubtedly in my mind, there are ingredients of the active ingredients in consumer video games that could lead to brain changes in a meaningful and sustainable way, that they're there. But because these games are built for entertainment purposes, I don't think they're going to go there as far as they can if they were designed with an understanding of the brain and cognition in mind and the population you're trying to impact. Right. But on the flip side of that, you also don't want to build something that's not fun and entertaining. And that's what makes this field so challenging. To build from scratch and reach something that has the engagement, immersion, and enjoyment that a video game does, because people have a pretty high bar for what they expect out of a video game now, especially young people. They're like, that's not fun. I'm not going to engage in that. So to get there and then to also have all of the mechanics and the video game engine itself target these brain processes, to do both of those, that's the ultimate challenge. And I think that's why we don't have a ton of examples of this being done at a really high level, because it is so challenging and requires, it's expensive, and it requires people working together that traditionally have not. Right. And so it requires an openness and a communication between professionals, both of whom feel that and are experts, video game professionals and artists and engineers and designers talking with scientists, both very strong-willed people, high-level performers, both feel that they know how to do their job. And you're like, no, you're actually not doing your job. You're doing a new job that never existed. You're creating something together that's a hybrid. That's the challenge.
One of my, the mention of first-person shooters reminds me of one of my more embarrassing outings in any activity ever was, I think it was my first game ever, and I could get this wrong. Pretty sure it was Halo. It was my first game ever, and I sat down to play this guy who I literally felt like I couldn't be on screen for more than a second without dying. Ended up being this guy named Fatality with eyes as the ones, who I think is a world champion.
I think if your name is Fatality, you don't want to play video games against him.
But the hand-eye coordination and just his ability almost like presciently to know exactly where I would be in this sort of three-dimensional artificial space, this virtual space, was mind-blowing. I mean, I could not believe how fast this guy was. I'm going to switch gears for a second, because I want to talk about some of the other aspects of your life as well. But what books, they don't have to be science related, what book have you gifted most often to other people?
I'm a big fan of science fiction books. Most of my reading is on the future. I'm really mostly satisfied when I'm reading books that's describing future possibilities and realities. You know, I read a tremendous amount for my work, and so I read articles all the time. And when I'm not reading that, I find it most gratifying to just push my creativity and not read about things that other scientists are doing, but read about potential futures. So, you know, starting with Asimov when I was a kid, Foundation series, you know, life-changing for me as a kid, and still have read it multiple times throughout my life. So that's probably that's probably the biggest share that I've done, is introducing people to Asimov and the Foundation series. And, but I continue, you know, I'm reading right now, books, by, author Peter Hamilton and others that, The Reality Dysfunction is a book that I tell people to read all the time.
What was the title?
It's called Reality Dysfunction. It's a series called the Night's Dawn Trilogy. Takes place in the distant future. Great technology, great human interactions, and it just stimulates my creativity to read really talented authors that are describing future possibilities.
Now I want to drill into that because I love science fiction. Love fantasy too. I'm kind of a fantasy nerd from way too much Dungeons and Dragons. I think also from too much Dungeons and Dragons, I tend to get obsessed with world builders. So like Frank Herbert and Dune blew me away. Stranger in a Strange Land,
Read 'em all.
Heinlein also. What aspect of reading science fiction, what aspect of the science fiction helps you to push your creativity?
I'm also a fan of world, or even, you know, beyond that, like sort of the space opera genre where you just have so many characters and ideas interacting over thousands of pages. Those are my favorite things to read. And, you know, there's a lot of that out there. It's a definite, you know, category within science fiction and fantasy. I mean, no doubt I'm inspired by futuristic technology. You know, people that have some background, that are smart enough to come up with things that are far beyond our capabilities, but reasonable, really excite me. So I would say that that's the part that drives, you know, my creativity is thinking about the technology and saying, wow, we don't have that. What would it take to have that? You know, and sometimes you just can't get there, but it sits in my mind. And even now in the lab, when I'm seeing all these things coming together, and sometimes I'm talking about it with someone, I'm like, it sort of sounds like I'm describing a science fiction book, but it's what I do every day. So I guess those worlds are starting to meet.
Well, so we watched we watched a movie recently. I guess it's Ex Machina is how you perhaps say it.
Exactly.
Of the machine, or from the machine, I guess technically. Which seemed imminently feasible in a lot of ways, which made it fun. You have a project that's going to be getting underway soon that I'd love to hear you talk more about. I'm not sure if this is the official name, but the nickname at least, Neuroman.
It doesn't really have an official name. That's the name that we call it around the lab.
I like it. That's
the Neuroman Project.
So tell me about the Neuroman Project, because you work out every day, or is it
5 days?
5 days a week.
Yeah.
Very fit guy. You've got the silver fox thing going, which I'm really envious of, because I do not have that. I have sort of the True Detective Woody Harrelson thing going, and moving into hopefully Jason Statham territory. But I digress. Where the hell was I going with that? Oh, you're very fit. You're very sharp cognitively. And yet, or I should say, most interestingly to me is this experiment or series of experiments you're going to be jumping into. So tell us and tell me more about this.
Okay, so this is a recent development in my life, is this Neuroman project that we're calling it. Sort of a fun title and a fun idea. You know, as a scientist, we have a very prescribed, regimented methodology that we go about doing an experiment. You know, very carefully placebo-controlled, blinded experiments, very rigorous analysis, very careful comparisons against, other groups. And that's what we do and what we'll always do. That's how science works. That's how we're going to figure out if many of the approaches that we're taking in this lab actually work, the approach of validation. And while we're doing that, what I'm seeing happen is we're developing all these new games that are really exciting. Three of them we've been working on for 2 years now. And it's going to take us a long time to figure out if these work and to really understand the mechanisms and the individual differences, why some people respond, why some don't. But what's going to take us even longer is to figure out how these games interact with each other.
Right.
Because I don't think there's not a holy grail out there. There's not one thing that's going to fix us or elevate us to our satisfaction. What's most exciting to me is what we call a multimodal approach. How do all of these games interact to elevate you? What are there synergistic effects? How do they add on each other? Maybe pharmaceuticals can be dropped to a way lower dose and be act to enhance it. Brain stimulation, neurofeedback. We do all of these things in the lab. And it's going to take us decades to look at how these all interact. But given that we don't think certainly the video gameplay is likely to be very dangerous, I have decided to do a very unorthodox study on myself, more of a project, to sort of what I say to the lab is put my time where my mouth is and say, I'm going to treat myself like a research participant, even though it's not a formal study. There's no control group. More of a case study, which exists in our field in many ways, and play 3 of our games, MetaTrain, Body Brain Trainer, and Rhythmicity. I can tell you what those games are. Play them all concurrently, which we don't do. We usually study one at a time. We've only studied one at a time, and these are in study right now. Play them all at the same time over the same period of time for 2 months, and see what I can do to my own brain, my own cognition, other aspects of my physiology. And so that's one goal, is to see, if I look across so we'll be doing everything in pre and post testing on me that we normally do in a study. So MRI, structural and functional, EEG during cognitive testing, stress measurements, blood work, inflammatory markers, epigenetics, sleep recording, all of that over a 2-month period, before and after, many things during, to see how engaging in these change these levels. And we have, dozens and dozens of 20-year-olds in the lab that come into the lab as participants, as data to act as a sort of baseline. So my question is, well, how do I compare on these metrics to a 20-year-old? I'm 46 right now. And with this type of training approach, what can I do to move these metrics closer? How close can I get? Or can I exceed them? So that's one challenge.
Turn to the womb. Maybe
right.
to like age 3.
Yeah, well, that would be a downswing.
No, I'm kidding. I'm totally kidding.
Seriously, it's actually a really good point, because there is that turning point, this sort of peak where you develop, and then you don't really plateau for very long. We think, and a lot of data suggests that. And that peak is probably for these type of abilities maybe around 23 years old. So that would sort of be some of the highest levels we see. So the project gives me the ability to just have fun and see what I can do with my own abilities, using approaches that I designed, that our lab developed. But, there's other benefits. It gives me like a very humbling experience of being a participant in my own lab and learn it from that perspective, like where it's a burden, where it's not. I get to see my games that I've designed from the inside out, like how they really function. I think that I can improve all these games by the experience and even improve my skills as a game designer through this. And so I think there's a lot of real benefits. It's definitely nothing that I've ever heard a colleague doing. I mean, the reality is some people work on things that would just be plain inappropriate or dangerous experimental drugs, but, where we just don't know the side effects, and it certainly would be unwise. But, I think in this case, because of the type of interventions we're working on, I really have a sort of a little opening to do something pretty fun.
No, I'm very excited about this. I wanted people to hear about it on the podcast because obviously we'll want to follow up. But the N of 1 guinea pig sort of Adam 2.0 project is not surprisingly very fascinating to me. What could you go through the 3 games and explain each of them?
Sure. So the 3 games, MetaTrain, Rhythmicity, and Body Brain Trainer. So MetaTrain is an iPad-based game. We've been working on all of these for years. This started as an NIH-funded study. And what the original design was,
National Institute of Health.
National Institute of Health, correct, where, a lot of the more traditional scientific funding comes in. And it's been challenging to get video game therapeutic research funded, but it's slowly happening. And so what MetaTrain is, I was inspired by mindfulness practice and some of the data showing that these, contemplative practices that have been around thousands of years have impact on our minds and attention beyond stress relief, but even cognitive impacts. And so what I've done in MetaTrain is take design principles from concentrative meditation and integrated them with our video game mechanics of adaptivity and feedback and put it in an iPad. And then we've built this out several times with a big team here. Zynga philanthropically donated time and engineering support and money to help us actually build this out, which is really fun to work with professionals that are trying to do some good in addition to their standard bottom line. So that's what MetaTrain is. So MetaTrain teaches you how to better self-regulate internal distraction. At least that's what its goal is. And the hypothesis of MetaTrain is that if you learn how to do that through the game algorithms, that we'll see a benefit that you can hold your attention to your breath for longer periods of time without being distracted. But the biggest win is that we'll see benefits on other aspects of cognitive control, like working memory and other externally focused attention, and that we'll see changes in the brain and be able to understand the mechanisms of that. That's MetaTrain.
So a couple of real quick interruptive follow-ups on that. The first is, are you measuring things like cortisol, C-reactive protein, and so on primarily as related to MetaTrain?
We're doing that for all of our studies.
Oh, okay, got it.
Yeah. So,
but in your particular case, do you hypothesize the highest correlation in those biomarkers will come from MetaTrain?
Not necessarily.
One answer. Okay.
I think that all of them have the potential for stress management in addition to cognitive improvement, interestingly enough.
Cool.
And so I don't know. And that's an example of why this is not a great controlled study, because I won't be able to see the differential contributions of the different games. Yeah. But that's okay, because we have many studies that are doing that. Yeah. We have studies where all of these are done independently, and we'll see which has the most impact on that type of blood-based sort of stress-related outcomes. So we'll see that. So that's MetaTrain. BBT, we call it BBT in the lab, Body Brain Trainer. We built that one entirely in-house with our own game design team and game development team. It is a motion capture game that's played using the Kinect 2, part of the Microsoft Xbox One gaming platform, which is a pretty unique use of that platform. And what BBT does is that it challenges you both cognitively and physically at the same time in one integrated game experience. So it's the first thing that we know that's really designed from scratch to do this with adaptive algorithms, both in the cognitive domain and physical domain. So let me explain what I mean by that. All of our games are adaptive cognitively, meaning that as you improve, the game detects that on a second-by-second basis and then scales the challenge appropriately to your ability.
That makes it harder.
It's like
the better you get, the harder it gets.
It's like a personal trainer there every single second, picking up your abilities in a very quantitative way and inching you forward. And if you're overwhelmed, then it'll back off. But it'll hold you at a high level of challenge where it's not so hard that you're frustrated, not too easy where you're bored. That's like a big part of our game engine. So cognitive adaptive engines are part of BBT as it is MetaTrain. But BBT also has physical adaptive engines. So what I mean is that before you play BBT, you get a VO2 max, which determines, it's a way of determining at what heart rate you should be challenged to be right at that sort of anaerobic zone where we're looking for this type of benefits. What we then do is have our participants, including me, when I start playing this soon, wear a heart rate monitor, and we feed your heart rate into the game algorithm. So what happens is if you're under our goal, the game will push you to have larger amplitude movements, faster movements. Once you hit your heart rate goal and exceed it, it could titrate it back. So just like we do on the cognitive side, from a physical cardiac side, aerobic training side, we can also hold you right at that perfect level.
And how are those instructions delivered? Is there like a big mime on a screen that you have to mimic, or what is that?
Well, you're seeing your hands move, but that's really it. You're basically just being challenged with cognitive demands across a 3D beautiful game environment, pushing your working memory, your selective attention, your ability to switch between tasks. But you're not thinking about this from the cognitive or the physical perspective. You're just seeing these challenges in this sort of Mayan-inspired world that you're trying to return treasures to, and you're just grabbing for objects and making decisions and playing a game.
Got it.
And that's the goal, is to make it just a fun game that you work through over a 2-month period of time. So MetaTrain, in its current formulation, is played 3 days a week for an hour each session for 2 months. So that's what I'll be doing. So that's body brain training. Sorry. MetaTrain is played for 30 minutes a day, 5 days a week.
Got it.
At home. So MetaTrain is a home game. BBT we play in the Neuroscape lab, this new lab we have that we created just to be able to do experiments like this. We hope that this also goes home, but the technology is so new. We actually just today, interestingly enough, set a BBT in my loft. So I could potentially play. Actually, I think my girlfriend, Jo, is going to be training on BBT at home.
Cool. Very cool.
That's still an ongoing discussion, but she's into it. My lab's into it. So we might have Neuro Woman project going alongside. And now she's like, I want to do a MetaTrain as well. So we'll see what we do there.
End of two.
Yeah, end of two. I know, exactly. The neuro couple. So the last game that I'll be training on is called Rhythmicity. Rhythmicity is a game that we've been working on with an indie game designer, Studio B. And the hypothesis here is that if we have a game that, through adaptivity, teaches you to become more rhythmic, which is also a question, can you become more rhythmic? We think you can. We're going to document that you can through gameplay. And then the question is, if you are now more rhythmic, is your brain more rhythmic, right? Rhythm is a fundamental aspect of how our brain works. It's not just an artifact that we've discovered, that you have alpha, theta, gamma at different frequencies, but it's a core property of how our brain functions at a highest level, from attention, perception, memory, all are driven by these rhythms, and not just the rhythms in isolation, coherence and synchrony, phase locking between rhythms. So because our brain, as all of our biology and even all of our physics is rhythmic in nature, does becoming more rhythmic improve the rhythms of the brain, improve your function, and other aspects of cognition. And so that's the hypothesis. So the game is a fun game, similar in some ways maybe to a little bit of the interface in things like Rock Band and Guitar Hero. But instead of just playing different songs and having some level of complexity, adaptivity there, we have a very high level of adaptivity where we're feeding you more complex rhythms at a faster tempo with less time across the audio and the visual domain. So that's the last game, Rhythmicity.
What is the protocol? The frequency and duration of sessions?
Rhythmicity is probably going to have a similar protocol to MetaTrain, although we're still formulating that. That's the least developed. So both MetaTrain and BBT are already in study. Rhythmicity is just finishing game development, but will be ready for me in July for my training. It'll probably be 5 days a week, 30 minutes a day.
Now, you've spent a good amount of time, just coming back to the rhythm, with world-class drummers, have you not?
Yeah, that's actually how rhythmicity was inspired through my relationship and friendship with Mickey Hart, who's the percussionist from the Grateful Dead. We were doing a talk together in New Orleans for the AARP because he had a really profound experience in his life because his grandmother, who had Alzheimer's disease, and he was a caregiver for her. She didn't speak to him for a long time, and then he's playing the drums with her one day, and all of a sudden she just like got into the groove and said his name, and he was just blown away. And all of a sudden, music and rhythm, from being a tool of entertainment, became something more. And he's been different ever since. I mean, he's always been on this kick. He's spoken in front of Congress many times. We've spoken together at the White House and Congress together, South by Southwest, all over the place, about rhythm in the brain. And so I was really inspired by his own impressions and his own passion for rhythm as a therapeutic tool, and his own frustrations that no one's really done the study that I described to you. We know that people that have high levels of music training experience in their lives, when you look at their brains when they're older, they're not like other older adults. There are definitely some improvements and some advantages, but there's not really a carefully controlled study of what elements of music. I mean, there's many things that go into being a musician, and so it's provocative.
Not to mention just the kinesthetic element. Right?
Oh, exactly, and so many things, and so it's interesting. It's a signal. Something might be there. Same thing with meditation training. Very hard in a very carefully controlled study to pull out what are the active ingredients and is this element of either meditation or physical fitness or rhythm. So that's a commonality, is that these practices often sit in what we think of as alternative. And I don't think that is doing them justice, right? Because people they're not being prescribed. They're not really part of what we think of as medicine. Yep. And hopefully through these type of studies that we're doing now, where we take active ingredients of them, drop them in our game engine, and then do placebo-controlled studies, we'll start validating this at the level that professionals like, I would prescribe that.
Yeah, absolutely. And I mean, that opens up a whole Pandora's box, obviously, of insurance reimbursement and so on, so that it becomes more economically feasible and even attractive potentially.
For sure. And that's what we hope to see in the future.
Yeah. With drumming and music, just two quick side notes. One is there's a great short movie called The Lady in Number 6, which is about 30 minutes long. It's about the world's oldest living pianist and Holocaust survivor, 109 years old, named Alice, still plays the piano every day, which is a fascinating watch. The other, which is even shorter, is a YouTube video. I think it's 3 to 5 minutes long. Really blew me away because I have Alzheimer's and Parkinson's on both sides of my family. Mm-hmm. So this is, as you know from conversations, an area of great interest to me, and why I was, for a very short stint, sort of a dilettante neuroscience guy at Princeton for a year or so, and why I've enjoyed spending so much time in this lab, among other reasons. But it's a video, and I think if people just search Alzheimer's patient listening to music from his era, they took this gentleman, must have been I'd guess in his 80s, maybe even 90s, African American gent, pretty much mute, vegetative practically.
I've seen this video.
Oh my God. And then they take music that he would have heard when he was young and play to him, and he starts having holding an entire conversation.
Yeah, it's profound.
It's really profound.
Yeah, that's so when, Mickey and I first started interacting, I was looking for other examples of that and sharing them with him. There's so much we do not understand about the brain and its wonders and how to control it and how to allow our ability to impact it, improve our lives. And it's just, those type of things are inspiring. And if we could distill them down and make them systematic and reproducible, so it's not just some very amazing but rare event, but something that's reproducible and prescribable and deliverable, that would be just game changing.
Yeah, so it's not something you hope for, but something you can engineer.
Right.
What is the fascination with photography? And obviously those of you listening can't see this. You've got two gorgeous large dual screens cycling through photographs. I know you are an avid photographer. When did that start? And why did it start?
Yeah, these are some of my photographs from over the years. I have a couple hanging up here as well. never did anything artistic in my entire life until I was in my late 20s. And I was at my family's house, and my uncle, who had sort of recently married into my family, is a radiologist and also a very avid photographer, amateur photographer. But even more than that, he was very into collecting cameras and photography equipment. And he gave me a book by a photographer by the name of Galen Rowell, actually Bay Area photographer.
How do you spell roll?
Rowell, Rowell. And Galen, Galen. And he is one of the world's most amazing photographers. He unfortunately passed away right at the time that I moved here. And I had met him once at a lecture of his, and he was looking forward to discovering the brain because he had a great interest in cognition. And he wrote this book called Mountain Light that my uncle shared with me. And Mountain Light is an amazing book because one page is a beautiful nature photograph, and the other page is a complete text. And in there, it describes the nature experience, which was amazing to me being in New York or not exposed to nature all that much. The technical elements of photography, which appeal to my geek personality, all the little details and numbers to get it perfect. And then really a little bit of a view of cognition, which is my field, talking about perception and attention. And this was something that Galen really appreciated. And, page after page of beautiful photo and then all those descriptions just captivated me. Probably, what I'd call another epiphany, life epiphany. And my uncle saw that. I read the book for 8 hours, went up to his room and brought down a camera from the year I was born, a Nikon from 1968, and said, "Here you go. This is a gift. This is your camera." It was totally manual, almost impossible to use. He gave me like 32 rolls of film, like a case of unopened film, and then basically took me up to their balcony and overlooking this is Long Island, overlooking sort of a wooded scene, and taught me how to use the light meter. I went back. I was living in Manhattan at the time, going to medical school on the Upper East Side at Mount Sinai. And, my balcony overlooking Manhattan, I got really lucky. I had I had a support. I didn't even own a tripod then, and took a couple photos of this amazing sunset in August that after I had developed, I was like, they were just amazing. And I showed them people, and they're like, "You're a really good photographer." I'm like, I am, which wasn't true, of course, at all. I just got really lucky. But that early positive feedback made me think that maybe I could do it. And so I spent months being not a good photographer in Central Park, learning how to do nature photography, and it captivated me. And I went and spent many years traveling around the world doing photography. I started a company called Wanderings. I built my website, Come Wander, in 1999 using HTML, not even any program, and sold a lot of photos. I did my own printing. Most of my sales were to hospitals. Interestingly enough, I had a nice connection there, since at this point I was a neurology resident. Right. And I had a lot of, I had a captive audience late at night of all the nurses and other support team that are just sitting around with me at 3 a.m. in an ICU and say, "Here's some of my nature photography." And so I do my own printing, and we realized that hospital rooms, waiting rooms, ORs, ICUs could use a little bit of nature. And, they're just pretty sterile places. And so we started realizing that it was having a sort of profound impact on patients. And so I had a nature photography career for a while. People have often asked over the year, is there a relationship between me being a scientist and a photographer, especially when I was active in both of those things? And one part was quite obvious to me, is that to me, they're both an exploration of nature. Right. So that's what science is. You're looking for organization and meaning, and that's what you do in what I would do in nature photography is look for organization. And granted, in the photography, is more looking for aesthetic and meaning from an emotional response. And in the lab, you're looking for more of an organization at a different level, but they really weren't all that different.
No, not at all. I think often of this video. There's also an essay, and it's probably at this point a book, which is an interview comprises an interview with Richard Feynman, who won a Nobel Prize.
When you're asking me people that are successful, he was actually one of the first people that jumped into mind.
He's a great one.
Yeah.
I mean, bongo player, safecracker.
Yeah. I would put him at the top
Real
of the
character.
list.
So the video, which people should be able to find, if you search my name in the video, I've kind of tracked down a higher quality version, is the joy of finding things out. And, he would have these debates with some of his artist friends, and they say, well, you think on the molecular level and the beauty of the flower is lost on you. And he'd say, no, actually, I totally disagree. He said, if I understand the inner workings of the flower, I think it gives an extra layer of depth so that I have more appreciation of the flower. And, started learning to paint when he was well past his prime in terms of his career and his work with, after the Challenger disaster and so on and so forth. But, fascinating character. That's one of my favorite books. The Surely You Must Be Joking, Mr. Feynman.
Mm-hmm. Yes, I read that many years ago.
What a hilarious, incredible guy. You operate at a very high level in the lab, managing a lot of people, juggling a lot of different projects. What are your morning rituals or routines? What does the first 60 to 120 minutes of your day look like?
Little coffee involved, a little breakfast.
When do you wake up?
I wake up like 6.
I'm going to bug you with the details.
I wake up at like 6 to 6:30 a.m. No matter what time I go to sleep. I try to get up. I usually don't set an alarm. I'm very responsive to light. I have a big loft with open windows and skylights, and I don't close them in any way. And so I like to wake up with the light. So, easier in the summer, and get up, shower, coffee, small breakfast, usually like an egg or some protein.
How do you take your coffee?
Just a shot of espresso. So pretty straight up. And
how do you make your espresso?
I usually use an espresso. So just get it nice and fast. On a weekend, I'll go out and get a nice,
schmancy,
higher
San Francisco
quality
coffee.
cup of coffee. But, for the most part, I'm just really about just getting things done in the morning so I can get out of the house and usually go to the gym. So lately I go to the gym, train in the morning, before I start my work day.
What time do you get to the gym? So you wake up at 6:30.
Yeah, I'm at the gym, by 7:38. 8 o'clock. I'm actually just reworking my schedule now, which is why I hesitated for a moment, because I'm going to be moving to 7:30, where I'll be doing BBT training nice. as my physical workout in the morning, 3 days a week, starting in July 6th. But yeah, so traditionally I've moved between afternoon and morning workouts, but I've really been enjoying the morning workouts for a bit now. I feel really energized by it. So I'm in the lab. Even the fact that I, woke up, had breakfast, worked out in the gym, 30 minutes cardio, 30 minutes weight training is usually my routine. I've been doing it since I've been 17 years old in one form or another. And then, I'm in the gym by I'm in the lab at 9:30. So some people 10 at the latest, and most people are just like rolling in to start their day at that time.
I hate that feeling. I'm that guy who comes in and is just like, I hate you, Adam. You've already done more than I'll get done in the next 6 hours. The working out, do you record your workouts in any way?
No.
More of a kind of instinctive.
Yeah. I've been doing it. No, I mean, I have a regimen. I work out 2 body parts a day, 3 days a week. And then on the other 2 days, I sort of just have fun, do whatever I'm in the mood for. So that's my weight training workout. And then the cardio workout is bike, treadmill, or elliptical for 30 minutes.
And you and I were chatting before we got started with the record button pressed about exercise. And, I enjoyed getting into it, and I want to explore it a little bit because it seemed like we exercise perhaps for very different psychological needs. Mm-hmm. So I was mentioning that I almost always train by myself, and have historically, because it's been my meditative time, my time to, say, count, which is how a lot of people meditate. It just happens that I do it while moving in this particular case. And so I would almost always have earphones in, oftentimes even without music, just so people wouldn't talk to me, and I train by myself. But you seem to get something else out of it, so I was hoping you could just elaborate, because
Yeah, I've always, for the most part, always had a single workout partner over the last 20 years of gym time. And it's someone that's also very compatible from a physical fitness point of view of what they're trying to achieve. And it was my friend Brian back when I was in New York City, my friend Daria over the last 8 years here in San Francisco. And, there's an intensity there. You're definitely pushing each other to work out, both to get to the gym, to not miss, and also to get through like a high level workout, not cheat. But then there's also like just a little human connection, a little talking without an agenda, just what's going on in your day. What are you thinking about? Do you have any crazy visions you want to talk about? Some small talk. And I don't really have a lot of that in my life. Everything's pretty intense and pretty goal directed. And so it's I think a type of relaxation that, and maybe like a little bit of humanity that served a valuable role to me.
A little bit of therapeutic release, it seems. And what struck me when we were talking about this is that I don't have a lot of that in my day either, because I'm typically working by myself. Mm-hmm. Every once in a while, I'll work in one of the offices, one of the startups that I advise or have invested in. But I also need that type of therapeutic, non-agenda, no agenda time. But the way that surfaces then, the way that I satisfy that is by going out and having drinks. Mm-hmm. And I think that is probably one of the reasons. It's not because I do enjoy wine, but I don't feel compelled. I don't have a wine deficiency. I don't need to drink it 5 nights a week.
Right.
But I'll go out and I'll be like, okay, I don't want it to be 15 minutes long, so I'm going to have more than one drink. And so we end up kind of waxing philosophic for an hour. And so it just struck me that maybe I should start working out with someone, because it would satisfy that need, scratch that itch, and I would be less inclined to have like 3 glasses of wine 4 nights a week.
Yeah, I think it's a great place to do that. You also get the added benefit of having someone push you from a physical point of view, physical fitness point of view. But I mean, I agree. I think it's incredibly valuable. Everyone needs that just little open time to let their minds wander and to laugh and to say things that you're not so worried about, because you're not in front of an audience like I am frequently. And so I do think it's valuable. And if you're looking for a workout partner, I actually have a slot opening up.
That's true. We should, actually. You know what? Lightning strikes. And you mentioned Daria. So Daria, many of you know, I do, one of my close friends is Kevin Rose. He is married to Daria. And I saw something funny recently, which was somebody on Twitter said, at Kevin Rose just announced that he's moving to New York City. In related news, at T Ferris just changed his relationship status to "it's complicated."
That's awesome.
Yeah, I'm gonna miss those guys, but
yeah, me too.
I'd imagine you spent a fair amount of time in New York.
Yeah. New York is my home, my original home. I mean, San Francisco is most definitely my home now, and I love it here, and I have no intentions of leaving. Although we have so many good friends in New York now, and I'm very good friends with Kevin and Daria as well. But my family lives in Chelsea. My parents, my sister, and my other sister lives in upstate New York, and so I go back to New York all the time, and that's where I spent my whole childhood and early adult life. And going to New York to me, I always say it's like jamming like a bat, like a energy right into your brain. It's like charge you up, and no place I've ever been has that amount of just pure human energy. Yeah, it feels great. And so, even a long weekend in New York, I'm like, okay, ready to go back to San Francisco.
Well, I feel like it's kind of like holding on to the third rail. In a way, it's so stimulating that I find it excessive for my system past a certain point.
Yeah. I mean, in reality, though, having been someone that's lived there for a long time, it's different when you live there.
Yeah.
You learn like, the guy that sells you coffee on the corner and your way to go to work, and all of a sudden your block feels really familiar, and then your neighborhood. So it's not always like that when you're actually a resident.
Yeah,
but
I suppose that's,
it's not as much as you might expect. Once you live there, you do get into that routine, and it does feel smaller, but it's a unique place in how energetic it is and how energetic the people are. And so, I mean, I do agree. It's a lot.
It has a lot of horsepower per square foot. It's a very dense, energetic environment. Let me ask a couple of rapid fire questions. I always say that, and then I'm very long winded, so I'll try to keep them short. But the answers don't need to be short. They can be, though. When you are feeling down or self-doubt, fill in the blank, negative emotion, what do you look to for inspiration or to get you back on track? Or what do you do?
Well, I mean, in all reality, I'm pretty even-keeled in terms of my mood and in terms of my outlook.
Have you always been that way?
As far as I can remember. I mean, I don't really fluctuate all that much. I mean, I get stressed, and of course, something crappy happens and I'm bummed out. But I don't really get too derailed or get caught in a rut. I don't really have that many memories of that. Usually if I am derailed in any way, my favorite thing is just interacting with my friends, going out and having a nice dinner, getting a drink, and watching some music. Live music is a frequent source of release for me.
Live music.
Live music.
Any type?
I mean, lots of different music. I like what, most people would call it like alternative, which has changed dramatically from new wave to whatever it is now. But, yeah, I mean, watching musicians perform that are talented and passionate and feeling the vibe of the music and dancing and just being in a festival, like I love that. And so I'm a very, very social person for someone that's spent as much time in academics and a lab as I have. I throw a party every month, and I feed off of that human energy. And so I'd say if I am feeling not at my normal level mentally or emotionally, my social interactions is usually the way that I find to get back.
Well, you're very, I would say, extroverted also, so it's kind of medicine for the extrovert. Right?
I would say that's true.
Do you listen to music when you work?
Often.
What type of music? What is your most played band or track or station at the moment?
Well, I have a very unusual way, I think, of listening to music. I almost always listen to music I've never heard before. I have my favorites in the gym. I of course have a playlist. When I really, want a quick fix, I have my favorite of whatever that time is. Well, it changes all the time. I mean, most of the bands that I listen to, I might have just discovered a couple months ago. So like, for example, recently I've been using the Discover feature on Spotify, and you have these recommendeds, and I'll just let it go for a bit. And, if it like sort of in a bottom up way, something like triggers and I hear it, I'll be like, oh, let me listen to that. Oh, Tame Impala. Well, they're interesting. I sort of like their vibe. And so I'll listen to them for a while. Bands that have captivated me for a long time, like Radiohead. I like bands that, are explorative, musical styles, Dave Matthews Band. But for the most part, I really try to listen to as much new music as possible.
Cool. And you use Spotify on the desktop as well?
Spotify on the desktop, yeah, for the most part. So like when I'm sitting here, it's probably open right now on some screen here, so I was just flipping through. I look at what other people whose music taste I like, what they're listening to. Mm-hmm. And I keep like a pretty active playlist for my party. And I like it to be fresh. So I'm constantly, looking for music that can attract my attention away from what I'm doing. I'm like, ooh, I like that. And then once I hear that, I'll go and pull that band out and see what other stuff they've created and then listen to them a lot.
You walk into a bar. What drink do you order?
I mean, it really depends. I would say my go-to is a really nice whiskey, maybe with just a cube in it. If I'm feeling a little fancy, maybe an old-fashioned. There are sometimes I just want a glass of wine or a beer. So it really depends.
You're such a scientist. It really depends for everything.
It really does.
The whiskey, any particular whiskey?
I'm a rye whiskey fan. Rye first, then bourbon, and Scotch, then Japanese whiskey, and then a Scotch, I would say, in that order. And rye whiskeys, I mean, I like so many of them, and I'm always changing what's my favorite.
Recommend one, and I'll try it tonight.
Whistle Pig.
Whistle Pig.
Yeah, that's a good one. Sure.
I'll try just for the name.
Yeah, it's a great name. I think I have some in my lab.
I think that's my nickname.
Some in my office here. I could pull some of that out. Yeah, no, I mean, ryes are an interesting whiskey because they really were the dominant form of American whiskey pre-Prohibition, because the industry was more north, where, Pennsylvania, Vermont, New York, where rye did really well. And then with Prohibition and the move towards the move south with corn, and bourbon really exploded, which is still by far dominant. But rye's coming back, and I love it. It's really like earthy and just delicious.
I agree, 100%. Let's see. What biography is your favorite, if any? Do you read biographies?
I don't read all that many. I've read some on. I most recently read the Steve Jobs biography, the Isaacson one, which was pretty fascinating. Anyone that lives around this neighborhood, it's like you sort of have to read it. They could ask you to leave San Francisco, so that's a requirement. But when I was a kid, Ben Franklin, Teddy Roosevelt, I was really influenced by a bio. I don't even remember who wrote it, of Teddy Roosevelt, which was really pretty cool.
Why were you how did it influence you?
I mean, I like hero stories, I've always been attracted to people who have sort of challenged their status quo and were successful at it, and, sort of marched to their own beat.
I have a recommendation for you. Since you gave me Whistle Pig, there's a book called Tuxedo Park about Alfred Lee Loomis.
Okay.
Who was a masterful stock market investor, got out before, I think, the 1929 crash. He's one of the few who not only survived, but really exited at the top. And he was an amateur scientist, but one of those kind of old-timey, really impressive amateur scientists, like in the sense that Ben Franklin was kind of like an amateur scientist, but you're like, wait a second, and he financed this place similar to Bletchley Park in a way, which for anyone who's seen The Imitation Game will sound familiar, because that's where, of course, they were cracking Enigma. But he brought in scientists who would otherwise have no contact with one another to develop technologies, some for commercial use, but many of them for wartime use. Fascinating story.
Wow, it sounds great.
Yeah, and I mean, like almost all of these heroes, too, a very flawed character.
I'll put it on my list.
Yeah, it's a great book. If you had to choose between losing your hearing, your smell and taste, or one eye, which would you choose and why?
Oh man, that's bumming me out even thinking about any of those things.
I couldn't make it both eyes because that I think is too much of a...
Everyone would keep their eyesight.
Yeah.
I mean, you'd be too incapacitated by it. I would say one eye. I mean, I love food. Without even just smell alone, you'd lose so much of those things that give me pleasure, multiple times a day. And, like you just heard, I listen to music all day long. I mean, it would suck losing an eye, but at least I could see and hear and smell. So I'll go with that.
Go with one eye. And you'd get a cool eye patch out of it as well, probably.
Yeah, exactly.
What are your hopes for... let me rephrase that, actually. That's too speculative. What do you hope to do with virtual reality in the near future?
We don't fully understand the potential of virtual reality in any domain because it doesn't really exist. So even from an entertainment point of view, it's fascinating. But the ability to create such a real and immersive experience, both visual and sound, that's the real goal, right? And obviously haptic too, if we could have tactile feedback, but even just visual and sound. I mean, I don't think of it as a visual modality at all. To create that real experience in a setting that would otherwise not be, accessible to that type of experience gives us the potential to heighten the human experience in many ways. You can heighten it from a pure enjoyment perspective, which is where most of the technology is driving right now. But to use it as a way to elevate our minds is really, really exciting to me. And so we in this lab have been putting a lot of thought into what type of interactivity in a virtual reality environment would lend itself to enhance how our brains work and improve our existence. And we don't know all those answers, but we're experimenting with them.
And there's some really interesting things that it would seem you could do potentially in this lab also. I mean, if you had an Oculus and then, for instance, what are you've, I'm sure, seen this. It's effectively an unpowered treadmill with a waist harness, Omni, that allows you to run in any direction.
Virtuix's product Omni, which
exactly.
We're like slated on the top of the list. I just had a conversation with their president and CEO about that will be delivered to my lab as soon as it's finally out there. We're actually a Kickstarter investor in that. We're serious about our technology. We've invested in many Kickstarter projects, really many of which we haven't seen yet, but we're hopeful. And
but you've had 700 update emails, I'm sure.
Yes, a lot of emails. But so the Omni gives us the potential that we can actually move and walk in virtual reality. So that's incredibly exciting because the more I play BBT and think about embodied cognition, not being a floating jar with some fingers and eyeballs, but actually being a moving human being. I see the value in that. And so I love the idea of most of our games having an embodied format. And so virtual reality where you could walk in and move is pretty exciting.
Yeah, this makes me think of the sort of simulacrum. And, if we have the potential to create movies that have animals that are so photorealistic that they're indistinguishable to most people from actual nature footage. And if we're at a point in the very nascent game of virtual reality where we have something like the Omni and so on, it seems epistemologically arrogant to think that we are the only people at any time in any dimension who have achieved that ability. I mean, it brings up a lot of interesting sort of philosophical questions that would have only previously existed in like a freshman, undergrad philosophy class.
Oh, for sure. I mean, I'm even more excited about not using virtual reality as a way of expanding outward, but expanding inward. So we have a project here where we created something called the Glass Brain. If you look that up online, you'll see plenty about it and see some videos on it. But essentially, it's a high-resolution view of our brain, both structurally using an MRI scanner in our center here, as well as EEG to capture online electrical activity in your brain.
Oh, this is the animation that you showed me of Mickey Hart.
Yeah, exactly.
That's amazing. Yeah, you guys have to Google this.
Yeah, that's how we first did it for a gig that Mickey and I were doing. In many places, we wound up doing this, as I mentioned before, in front of Congress and South by Southwest and other places. But now we've keep advancing the technology, and we have a virtual reality version of it. So you could put on, let's say, an Oculus Rift, grab a Xbox joystick, and if we've already scanned your brain and we've done all of our processing and you're wearing an EEG cap, fly inside your own functioning brain, which is an amazing experience. And where do we go with that? Well, one really sort of amazing potential is that you can essentially play a video game using the signals in your own brain as the stimuli in the game.
Wow.
And
that
that's what we're exploring
really
that. So basically a very sort of futuristic view of neurofeedback where you learn how to control your brain rhythms by interacting with them sort of in situ in the place in your brain where they're coming from. And, this is what I was saying earlier when, what I do on a day-to-day basis starts sounding a little like my science fiction books. But we're there. We're doing this already. There's an image here. This is these two guys. So
the image we're looking at is two people sitting down. Looks like they have VR headsets.
Both of them have VR headsets. The person on the left is Mickey Hart. So Grateful Dead percussionist. He's wearing a VR headset and a 64-channel wireless EEG cap. He's in VR and he's playing a rhythm game, an early version of Rhythmicity.
And just for people listening, so 64 channel basically means 64
electrodes. Yeah, electrodes. So it's a high density cap, but it's mobile, it's custom built for this lab, and pretty exciting technology on its own. So he's in VR playing this game. He's looking at this beautiful space scenario with all Grateful Dead little shout outs everywhere, and he's having fun. And that's showing up on one screen. This is a 120 foot wide screen, 24 feet high, a keynote that I gave at the NVIDIA GTC conference in San Jose. So 3,000 people in the audience, giant screen. This is the demo after my talk. So Mickey's in there doing that. The guy next to him, his name is Tim Mullen. He's one of our head engineers, really brilliant guy from UCSD. He's wearing a virtual reality goggles on Oculus Rift, but he's actually flying inside Mickey's functioning brain while Mickey's in his own virtual reality. So I always think of it and say it's like Russian, like neuro-nested dolls, you know? Like Mickey's in his virtual world playing his rhythm game, wearing his EG cap, and Tim is just looking around his functioning brain while he's doing that.
So trippy.
Yeah.
I mean, how much of our current reality at some point are we going to realize is just like that set of nested Russian dolls?
Yeah. I mean, we did this live in front of an audience last year. You know, this is all possible.
I want to kind of sniff test a theory that has floated around for a few decades, and you may have come across this before, but I'd be curious to get your thoughts, because I just saw an article today. This was actually not an article. It was a link to a study abstract, which was, I want to say on PubMed, and it was looking at the historical use of hallucinogens by indigenous people, primarily in South America, to improve the hunting ability of their dogs. Really fascinating stuff. And we could go down that rabbit hole, but just to try to keep myself, talking about multitasking, try to keep myself focused for a second, there's a theory of hallucinogenic experience. And there are many theories, obviously, many of them completely speculation, but one of them is that the hallucinations are not all internally generated, and instead that the hallucinogens are basically deactivating filters that would otherwise block out this noise that we see or hear as hallucinations. Is that conceivable based on our current understanding?
I mean, we get a lot of signals into our brains through all the receptors we have. Obviously, there's many signals out there that we don't have receptors for. So I wouldn't think that hallucinogen would allow you to receive signals that you don't have receptors for. I mean, that would be a little bit of a stretch from my perspective. But, I mean, I never say never. I just don't have any hypothesis of how that would happen. But it is possible that you could be interpreting things that may have not been in your awareness or even been inhibited by your top-down sort of conscious control that is now released, not even just in hallucination, but in dreams as well. So, yeah, I think that, it's sort of coming internally, but your internal world has been painted and sculpted by your external experience. So I bet, it's some combination.
If you were to, we talked earlier about the multimodal approach, and let's just say you have Metatrain, you have BBT, and then you have rhythmicity. And you mentioned you could potentially at some point add in a pharmacological intervention, and potentially that the multimodal approach would allow you to get a kind of higher yield from a lower dose. What compounds, when you get to that point, or if you ever got to that point here, what are the compounds that would be kind of on the short list for exploring?
Well, there's a whole class of drugs that, fell into the cognitive enhancement domain that really became Alzheimer's drugs called cholinesterase inhibitors, boosting the acetylcholinergic system, acetylcholine system. And these cholinergic agents act pretty bluntly to, in many ways, improve attention. But there's a limit and side effects associated with higher doses. So I think it would be pretty interesting to see what they might look like at a lower dose, but when you're activating the attention networks appropriately. I think that is a really important question of how do they interact? We don't know that yet. Modafinil is a drug that has had some cognitive enhancement data that seems interesting enough to look at an interaction as well. So I'd say those two.
On the cholinesterase inhibitor side, are you looking at something that is potentially prescription medication, or would it be like a huperzine A? type over the counter thing?
I mean, there are plenty of prescription medicines out there that we
Is Aricept?
Yeah.
That's a cholinesterase inhibitor.
Exactly. That's the most prescribed one.
Yeah.
It's a drug I'm most familiar with because that's what I prescribe the most when I'm seeing patients. So as a neurologist, I saw patients for many years, and most of them had early Alzheimer's disease, cognitive impairment associated with aging, and Aricept was really our first line agent and still largely is. And, I mean, to me, it's still crazy. Like, we really give people these drugs when they have cognitive impairment, and most of the time we don't tell them to do anything, right? So it's like, to me, it's always like, like a bodybuilder taking steroids and not working out anymore,
Right.
or getting like, high performance oil for your sports car and then leaving it in the garage. Like, you got to run it through the engine to get
Right.
the benefits.
Yeah.
So I feel like we've really missed the boat in understanding how a really, like as I mentioned, blunt instrument like these neurotransmitter receptor modulators are, how they interact with something that activates a network in a selective way, like what you get from a video game.
And the modafinil, of course, well, I shouldn't say of course, but I believe it was originally Provigil, designed for as an anti-narcolepsy drug. Funny how many sprinters had prescriptions written for narcolepsy when that came out.
Now it's more broad than that. Now jet lag is on the list.
Now jet lag.
Yeah, and shift workers.
Do people at this point understand the mechanism of action, modafinil?
I'm not an expert in that, but I don't think that we fully understand the mechanism of action. I mean, I think I remember when I first started putting it on my list of things to prescribe as a neurologist, we didn't even know what receptor systems it acted on. It was just like, we don't know. We found this by accident, but it doesn't seem very dangerous. Matter of fact, it is pretty low in adverse effects and addictive potential. So it's a pretty good one. But now, from doing some reading, although we have never used in the lab, so I haven't dove so deep, it does seem like there's a lot of receptors that it acts on, and so I would say that we probably do not have a firm idea on the intricacies of the mechanisms that lead to its effect. Yeah.
What is the most exciting data that you've come across, or studies or otherwise, related to TDCS or technologies like that? And if you could explain for folks what that
is. So TDCS is a technique that falls into a larger category that I call TES, transcranial electrical stimulation. TDCS is direct current. Picture a 9-volt battery, right? And that's literally what we're talking about in terms of voltage and amperage is that at that level, very low. There's another related technique that we use in the lab a lot, which is TACS. So that's alternating current, just AC current. And then there's another technique that's also related to this because it's transcranial, which is TMS, which is magnetic stimulation. And all of these approaches have in common in that the way of using electromagnetic fields to influence the electromagnetic properties of our brain under the scalp, through the scalp, right? So not invasively, so not like neurosurgery or implantable electrodes, which we use also as clinical care for, like, example, Parkinson's disease. So, our brain is really an electrical machine and using rhythm as a fundamental principle. And so if we manipulate it, we can hopefully get beneficial aspects of it. You could get negative aspects as well, which is why I always feel that we're a little premature in putting this tool out there without more appropriate guidance and testing. But I do think there's exciting potential in this field. We actually just published our first TDCS paper that you contributed to, and I appreciate that.
Of course.
In several different ways, even as a data collector. And we showed that you could get some benefits, and this was just an opening study to start getting our feet wet with this technology in multitasking abilities over a very short period of time that you don't seem to get without it. Now, it's very subtle, but the fact that there's any change at all in a controlled study like that is interesting, to say the least. I mean, there are many, many papers like this from other labs showing that you can boost certain cognitive abilities by applying low electrical fields, low amperage electrical fields through the scalp, either DC or AC. But seeing it from your own lab as a scientist is always like, interesting. It really does seem to work. And now we have several studies going on using alternating currents where we can actually target rhythms in the brain, right? Because alternating current is essentially a rhythm. So we can make an alternating current at, let's say, 4 hertz, theta rhythm. We know that theta rhythms from the prefrontal cortex are involved in attention. As a matter of fact, that was the metric that was low in older adults in the NeuroRacer study beforehand that we normalized with video game play. So what does it mean if you're playing a video game, and we know that, we have the impression from our data that boosting this level over a month is what helped performance on this and even other tasks that we didn't train on the game. Well, how about if you play the game and we boost this rhythm by applying the rhythm across your scalp? Can we lead to a more rapid learning curve? So let's say you just got back from war and you're a wounded warrior and you have traumatic brain injury and you have cognitive impairment, and we have these games that target networks that are deficient in you, but you need a little extra boost of those underlying rhythms or the plasticity. Can we use an electrical current during gameplay to lead to a more effective outcome? That's what we're interested in.
That is a cool study.
Yeah, we're doing that.
Super cool. Well, Adam, I know that we're gonna go paint the town red after this, so I want to be cognizant of budgeting enough time for us to really get into trouble. But a few last questions. One is, if you could give your 30-year-old self some advice, what would that advice be?
Let's see, advice to the 30-year-old. I would say to have no fear. I mean, you got one chance here to do amazing things, and being afraid of being wrong or making a mistake or fumbling is just not really how you do something of impact. You just have to be fearless.
I like that. And last, where can people learn? No, this isn't the very last.
Okay.
That was a head fake.
Second to last.
Second to last is where can people learn more about the lab, photography, everything?
Yeah, so we have a lab website. The shortcut in has a long edu, but gazlab.com, GAZZLAB.com will get you there pretty quickly. My last name, Ghazali, made up in Ellis Island, is an entirely unique name as far as I can tell by Google.
SEO optimized.
Yeah, it's perfect. So if you search my last name, Gazzaley, you'll find tons of links to talks I've given, to my photography, to our lab website, to lots of media surrounding the type of work that we do.
And the final question is, if you had an additional $10 million just came in a Secret Santa envelope or whatever, what might you do with that? Because I mean, when we sit here and play on the whiteboard, I'm always just blown away by kind of the number of not just options, but attractive, interesting, impactful options that you have. What might you do with that?
I would just do exactly what we're doing. I would just funnel that right into the momentum that my lab already has. The things we're doing are pretty edgy for traditional scientific funding sources like the NIH, which also happens to be pretty broke right now. NIH, the National Institute of Health, is at an all-time historic low in terms of their funding of science. Not great times. So we're forced to go to non-traditional sources like philanthropy to try to get money from people that believe in what we're doing to do this work. This work is expensive. We have to hire experts, programmers, and we're trying to get cutting edge technology into the lab, and it takes a lot of money and time and expertise. And so there are things that I want to do, technologies I want to try, people I want to hire that we just don't have the resources to do. We have the vision of what we want to do. We have more games we want to build. We want to look at how the games interact. These studies are large. They're expensive. I would just, funnel it into our ongoing research program and try to get it to the next level as rapidly as possible.
I like it. I like this plan, Adam. And the other plan I like is going to maybe go out and have some wine as our cognitive handicap.
Yes.
Before we get back to the
Sounds
focus
good.
on cognitive enhancement. Thank you
Sounds
so much
great.
for the time, man. Always fun. And everybody listening, check out the lab. Check out Adam's work. And we will be definitely following Neuroman and the adventures of Adam and co. Very closely. For show notes, guys, links, resources, etc., books, things we talked about, just go to 4hourworkweek.com/podcast. And until next time, thank you for listening.
Thanks, everyone.